Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is SYSZARINNA binti OMAR from RY40 System Electronic in University Malaysia Perlis. Today, I will present about my Lab 2 Operational Amplifier, Comparator and Summing Amplifier. Objective for this lab is to demonstrate and investigate a comparator circuit and also to demonstrate and investigate a summing amplifier circuit. Okay, firstly we do the comparator zero level detector. This is the circuit. Ports the input V in and the output V out with V in 20 V peak to peak sine wave at 1 kHz. Okay, this is the circuit. I already do the circuit for zero level. Inverting negative is grounded to produce a zero level. Non-inverting positive input is connected with input signal voltage. When the sine wave is positive, the output is at its maximum positive constant level. When the sine wave across zero, the amplifier is driven to its opposite state and the output goes to its maximum negative constant level. Okay, if you see here, whenever the voltage reaches zero, the output has produced and get the square wave. The value has increased from here, negative 9 equal to negative 10 volt to negative 13 volt. Okay, it should be more because we put in here is 15 volt. So when we run the circuit, it cut off and get less than 15 volt. So it will be negative 13 volt. Okay, for second circuit comparator is non-zero level detector. This is the circuit for non-zero level detector. So the lab given a table for resistor 1 and resistor 2. Okay, firstly connect the resistor 1 with 4.7 kilo ohm resistor and R2 with 1 kilo ohm. Okay, and V in time V peak to peak sine wave at 1 kHz. So for non-zero level detector, we have to find the voltage reference VREF. So this is the formula. VREF equal to R2 over R1 plus R2 multiplied by voltage. So I already calculate the using the formula given. So for resistor value 4.7 kilo ohm and 1 kilo ohm, I got the 2.63 volt. Okay, this is the circuit that I already simulate. Okay, if you see here, if you see point here, you get the 2.8350 volt. So it's almost the same with I calculate for VREF 2.63 volt. So if you see up here, this is the maximum positive voltage 15 volt to negative maximum voltage which is negative 15 volt. Okay, after positive maximum voltage reach in point here in sine wave at VREF 2.8350 volt, it will become down here to negative maximum voltage which is negative 15 volt. Okay, for resistor value 1 kilo ohm and 2 kilo ohm. For value voltage reference, we got 5 volt after I calculate using the formula given. So this is the circuit for non-zero resistor value for 2 kilo ohm. So if you see in here, we get 5 volt for um voltage reference. Okay, it will never go more than 5 volt because we only input the voltage 5 volt of the voltage input. Okay, it will stop at negative 15 volt because it's the maximum voltage. Okay, for resistor value 1 kilo ohm and 1 kilo ohm, I already calculate the voltage reference, so I got here 7.5 volt. So this is the circuit that I already simulate. Okay, it's still the same with non-zero resistor 2 kilo ohm. So we reference here we got 4.9 volt, which is 5 volt. So it will never go more than 5 volt because we put in here is 5 volt only in voltage input, and also it will stop at negative 15 volt because it is the maximum voltage. Okay, for 4.213, construct the summing amplifier shown in figure 1.2 using resistor value in table 1. So this is my circuit that I already simulate. I got the waveform same with non-zero level detector. The VREF still 4.9 volt. It never go more than 5 volt because we put in here 5 volt in voltage input, and it will stop at negative 15 because it's the maximum voltage. Okay, next circuit is summing amplifier. This is the circuit for summing amplifier, and this is the value for resistor given. And input of V1 equal to V2 equal to 2 V peak to peak. Okay, this is the circuit that I simulate. Okay, so we have 1 volt here and 1 volt here in the voltage. And okay, I already calculate the V out using this formula. V out equal to negative RF per R1 multiplied by V1 plus RF per R2 multiplied by V2. So I got negative 2 volt. So if you see in here, for 1, here, I got the negative 1.9, so which is negative 2. So if I got 1 millivolt, negative 1 millivolt, so I got here in 2 volt. So this is for all resistor 10 kilo ohm. For different resistor here 2k and 10k ohm. So I also calculate the V out equal to 1 volt. So I got negative 6 volt. So in here, I got 1 millivolt, same with the voltage that I put. So I got negative 5.9, which is negative 6 lah. And here, negative 1, so I got here 5.993 volt, which is 6 volt. Okay, I will answer the question given. 1. What do you understand about summing amplifier? Okay, summing amplifier is a versatile device used to combine the signal. This amplifier add the signal directly or scale them to fit some prearranged combination rule. This amplifier is used to apply a DC offset voltage with an AC signal voltage. Okay, question number 2. What happens to the output if the frequency of the source is increases to frequency 3 kHz. Briefly explain. If frequency of amp is increased, the gain of amplifier is decreased. Okay. Conclusion in this lab is from this lab experiment, student must be able to demonstrate and investigate a comparator circuit, and other than that, demonstrate and investigate a semi amplifier circuit. Okay, that's all from me. Thank you.